Okay, so not just is it continuous, but find the value of A and B so that it is continuous. So I guess there's two things you could do on this type of question. One, which doesn't normally work, is you could just try, guess, and check. You could try a value at A and B, and then you could basically work it like we did the other one, see if it's a yes or no. That's not a good long-term solution, though. Instead, I'm going to draw the visual here, even though it doesn't say you have to, because I think it makes it a little more obvious what you're trying to do. And I'm not just saying this is what you need to do for step one. If some of the graph looks like this, that's the top equation, and some of it looks like this, that equation, then if you're trying to find the values of A and B that makes this continuous, I'm trying to find some line that connects these perfectly so that my whole graph is continuous, right? So I'm trying to figure out what value of A and B make that true. Well, with the visual, I guess I can almost piece together the slope and the y-intercept. I guess I could check it, and that would make sense in this question. But really what I'm wanting to do is I'm wanting right here where it's black and green, I want to make sure they have the same y values for that x value. I don't care that the y values are different at other times, but when x is -1, I need the y value of my black equation to be the y value of my green equation. So if I only care when x is -1, I can plug that in, and I get that 4 is supposed to be -a plus b. All right, well, is that what we need? I mean, can I solve this for A or solve this for B? No, one equation is not enough to solve for two variables. So you got to have the same idea down here. I want my green equation to have the same y value as my red equation, but only when x is 2. So when x is 2, I want ax plus b to give me the same thing as -4. Okay, so if I plug in 2, I get that. And now I've got two equations, two unknowns. So now I can work this like a system of equations. So I'll put this one on top, maybe put this one underneath it. And how you want to solve a system of equations, you've got elimination, substitution, you got a calculator, you can do matrices if you remember matrices from Algebra 2. I actually helped one of my advisory students with a question like this. I guess they're doing this in Algebra 2 right now. I would probably do elimination, where I just try to add these together. But if I add these together, neither A nor B goes away. So I would probably multiply this bottom line and multiply everything by 2. And then add them together, because that would make my A values go away. And if my A values go away, I'm going to be able to solve for B. And if I can solve for B, I could then plug it back into either one of these and then solve it for A. And if I made this the thirds, times, so 8 thirds is -A, so positive A would be -8 thirds. So definitely a little more leggy with the algebra, but the calculus piece, understanding what it means continuous, you're just trying to get this to fit in perfectly. So specifically, I want the y values to be the same for this x value, and I want the y values to be the same for that x value. The rest of the time, the rest of the challenge is just being consistent enough with your algebra that you can get the right answers. Yeah.
On the 6 and the 7,